Okay, so for number 7 and 8, you can choose to solve these either way using substitution, elimination, or graphing. There is usually one easier way to do each problem though. So if I'm looking at number 7 here, I've got something equal to y. This 3x plus 3 is equal to y. And then I've got an equation in standard form up above. So what I would do is I would take this 3x plus 3 and I would plug it in for y there. So we're going to use substitution here. That would be the easiest method to do for this problem. So I'm going to have 2 times, in parentheses, 3x plus 3. And then I have to write the rest of the equation, plus x equals negative 8. Now I just got to do some algebra here. I'm going to start by distributing. So I get 6x plus 6 plus x equals negative 8. Now 6x plus x gives me 7x. I combined my like terms here. There's an imaginary 1 in front of this x. And then I'm going to subtract 6 from both sides. And I get 7x equals negative 14. Be careful with both of those negatives. Divide by 7. And I get x equal to negative 2. But I'm not done. I have to plug it back in. So if I know that x equals negative 2, I'm going to plug that into my equation for y in for negative 2. So that equation is 3x plus 3. But instead of x, I'm going to plug in negative 2. So I have y equals negative 6 plus 3. So y equals negative 3. So your final answer is always written as a coordinate. So x comes first, negative 2, and y comes second with negative 3. Looking at number 8 here. Number 8, we should be seeing that there's no y equals or x equals, and they're not both in the form of y equals, so it's going to be a little harder to graph and use substitution for this problem. So for this problem, we're going to use elimination. Okay, first thing to always check, are my x's lined up on top? Are my y's lined up? Equal signs and numbers, they are. I cannot just add these right away though because there are no opposite coefficients. So up to us, we get to decide for this one, do I want to eliminate my x's or do I want to eliminate my y's? I'm going to eliminate my x's here. But you could also eliminate your y's and you'll get the same answer. So the opposite of 2 would be negative 2. So to make this 1 into negative 2, I need to multiply this entire bottom equation by negative 2. But before I multiply it, I'm going to just go ahead and copy this first equation down below, so that way I have it right next to the new equation that I'm going to have. Okay, so now we're going to distribute this negative 2 to all 3 terms on the inside to give me negative 2x minus 2y equal to 8. Now, if I add these 2 equations together, I'm going to be able to eliminate a variable. I'm going to eliminate x. Negative 3x plus a negative 2x is negative 5x. And I made a mistake here. This should be a negative 8. Negative 8 plus 3 is going to be negative 5. So my last step, divide by negative 5 on both sides. You're not adding it because it's being multiplied by the y. And then I get y equal to positive 1. Now I'm not done because I got to go back and solve for y, so I'm going to plug in 1 into either equation. It doesn't matter which one. I'm going to choose the second one, and then I'm going to solve for x. So x plus y equals 4. I'm plugging in 1 for y, so x plus 1 equals 4. Subtract 1 from both sides. We get x to equal positive 3. So your final answer as a coordinate would be 3, 1. X always comes first.